Okay, hi everybody. This is the Math 31 applications review. This is question 18. At 10 a.m., a plane traveling east at 100 kilometers an hour is 150 kilometers west of a jet traveling south at 200 kilometers an hour. At what rate is the distance between them changing at noon? Okay, so here's the situation right here. Here's this plane A. Okay, it is 500 kilometers, okay, west of a jet. Now this one is traveling. Let's maybe call that distance there, the distance that it's going here, little a here. We know that dA by dt, and in this case here, I'm actually going to label this a little bit differently than I did in the previous question, just to illustrate a point here. I'm going to call this distance here, I'm going to make the axis right here, I'm going to call this distance here negative 500, and I'll say that dA by dt, because it's traveling east, will be positive 100 kilometers per hour. Now the jet here is traveling south. Okay, now it starts right at the origin here, and let's say that jet is B. Let's say that it's going down here, so we'll say dB by dt. Now because it's traveling south, okay, I'll give it, what do we got here? I'm going to give it negative 200 kilometers per hour. So in this case here, different than what I did previously, here I'm assigning the negatives based on the relative direction that we're moving here with respect to the origin. So anything to the left, anything moving to the left would be negative. So this thing is to the left, negative 500, but it's moving to the right. This one is starting at the origin and moving down. So we want to know how fast that distance between them is changing. We'll call that d. So what we've got here is a squared plus b squared is equal to d squared. Once again, I probably chose that a little bad, but regardless. These are all variables changing in time, so I will take the derivative with respect to time. So 2a dA by dt plus 2b dB by dt equals 2d dd by dt. Okay, now the 2's will all cancel. Now remember, I'm looking for dd by dt, so this is going to be a dA by dt plus, whoops, sorry, I got to give myself enough room for that, plus b dB by dt all over d equals dd by dt. Now I do know most of what I need to know here. Now this is at 10 a.m. and we're asking for the speed that it's changing at noon. So it's 2 hours later. So this is the information that we're going to get here. The a value at that point, okay, the distance that the first plane is away from that origin, that starting point here, that is going to be, well, I started out negative 500, I'm going 100 kilometers an hour for 2 hours. I am going to be negative 300 kilometers at noon. This jet here was going south at 200 kilometers an hour. Now 2 hours later, that's going to be negative 400 kilometers, okay? 400 kilometers south of the origin there. So now I can plug that information into this equation here. So this is going to be negative 300 times the speed. Now the speed in this case is going to be positive 100 plus b is going to be negative 400, but its speed is negative 200. Okay, all over. Now I didn't figure that out yet. Okay, haven't actually figured out the distance between them, but the numbers were chosen on purpose. If this is 300 and this is 400, d is going to be 500, and it'll be positive 500. Okay, when you square those two distances, add them together, take the square root. All that squaring is going to get rid of the negatives there, and it's going to be a positive value there. So this will all be all over 500. And so now I just got to work that all out. So that is going to be in brackets for the numerator. That'll be negative, where are we going to get there? 30,000 plus, okay, well this is going to be 80,000. Okay, and I'll divide that by 500. And it looks like really nice and simple, really easily simplifies down to 100 kilometers per hour. And there you go.